Yeah. So question is asking out of these four, which of the following, which of the following will give fastest SN1? So out of the following, who will give the fastest SN1? Samanvi VVL. You know what does it mean? Huh. Please check if that is comfortable. Just try to sit on that once. Yeah. Okay, it is manageable, I guess. Be seated, be seated. You won't fall. So they're asking which of the following gives the fastest SN1. So first of all, for SN1, we check the carb cation, right? SN1 forms a carb cation. So you can check here that in all the cases, there is a carb cation formation. How do you get the carb cation? Remove the old nucleophile. So halogen, all have same halogen, gone. Now tell me what is the degree of each carb cation? This is 1 degree, 1 degree. So they all have same leaving group. They all have 1 degree carb cation, right? Now the question arises is, then how do we decide who will be the fastest and who will be the slowest? So remember, rate SN1 reaction is depends on stability of carb cation, stability of the carb cation. So can you tell me where the stability is the most? A, why A? Why RNA? Why B? First of all, Saman, what happened? You seated comfortably? Yeah, for today. Now, so tell me what is OME? ME means methyl and OME means it's basically OCS3. It's called methoxy. It's a methoxy group, right? Is it clear? Now understand, like I told you, carb cation means there is a deficiency of electron. So you have to see who can support the deficient carb cation. So where the support will be more, understand CN is a very strong minus I. It would rather deplete the electron. See, it's already having loss and it will deplete even further. NO2 is even stronger than CN. It will deplete even more further, right? Already it has a loss and more electron will be depleted here, right? So D is going to be the slowest. D is going to be the, and C will be the second slowest because these two are electron withdrawing groups. What they are? Very, very strong minus I groups. This is also minus I, electron withdrawing groups. Very strong, right? But A and B are having a good friendship. They have plus I group. So methyl versus methoxy, who is more stronger plus I? That will be the fastest because their carb stability will be the more. So answer will be methoxy. Methoxy is a better plus I as compared to methyl. Clear for everyone? Methoxy is better than methyl. Yes. Yes. What is? Plus I means electron donating group. Minus I electron withdrawing group. Carb cation has a loss, or yes or no? Plus means loss. So who can fulfill the loss? Who will fulfill the loss? The one which can give the electron or take away more electrons? Exactly. So who can better give it? Methoxy. That's why B is the answer. So do you know what is the overall order will be? If I say decreasing order, so it will be B, A. B is the slowest. This is the second slowest. Right? And now, how many people do remember the minus I order correctly? That is the prime basic thing. From grade 11, I have been telling you minus I order, minus I order. Okay. So at least remember, guys, this much. NO2 is the strongest minus I. Can you remember this? Who is the strongest? After the, after that we have Sino, CN, another one. These two are very, very strong minus I groups. After that, something with carbonyl carbon, something with carbonyl. Tell me which functional group contains this? Ketone, aldehydes, carboxylic acid, all these. And then fluorine, chlorine, bromine, and please remember this much. The full-fledged version, slowly, I'll make you remember anyways. But basically, any student must remember this. Okay? Minus I order. Remember, minus I will destabilize the carb cation but stabilize the carbon ion. Keep that in mind. So whenever you have a carb cation, it will destabilize it. But when you have a carbon ion, it will stabilize it. So write it down. It stabilizes the carbon ion but destabilizes the. So when there is a negative charge, we need someone who can pull the electron. But when it's a deficiency, we really don't need them. We need someone who can donate. So alkoxy and alkyl groups are plus I groups. Opposite to minus I, we have. So minus I group is called electron withdrawing group. Is it clear? See, full-fledged version is very long, and I am really not expecting you to remember all at once. I tried in 11th and I failed. So better you at least remember this jugad. Basic, at least this much you remember, okay? Slowly, I'll make you remember the full-fledged version. Yes. So plus I means electron depositing group or donating group. Correct? No. Is it clear? Guys, negative charge, what do you mean by negative charge? More electron or less electron? See, hmm? I'm asking you, negative means what does negative indicates? More extra electron or less electron? Extra, right? Tell me, generally you go to, a friend's place or you go to a restaurant, right? You go to many places for eating, right? So after you eat full, do you order more food or you order something which can help in digestion? Something which helps in digestion, right? Same thing is there. When there is more electron, you need something which can pull out the electron, right? Because there is extra electron. So that is why we require minus I group in those cases. Is it clear? And when you are hungry, you order the food, right? You don't eat something which will make you even more hungry, right? So in that case, understand when there is a deficiency, means plus charge, we need something to be, donating the electron. In those cases, we look for plus I groups. I hope that is clear now. Okay. So electron donating. So what are these groups? They are alkoxy group and alkyl groups. What they are? So remember, bigger is better. Keep that in mind. Bigger the alkoxy group, bigger the alkyl group, better the donation. Better the donation. Simple. So remember, they stabilize, they stabilizes the carb cation and destabilize opposite. Destabilizes the carbon ion. Opposite, right? Because they are donors, so they stabilize the poor, which is carb cation, and destabilize the rich. They are electron donating groups, right? Withdrawing groups. So they destabilize the poor and they stabilize the rich. Simple. I hope it's clear now. No doubt. This is a basic core of chemistry. It's applied everywhere. It's not about this topic or this chapter. So this is a core you need to remember. This is the basic. Is it clear? Okay. Let me understand how many people understood this. Okay. Mm, Tell me who will answer. Yeah, Ridhima, answer my question. Out of these two, who is a better plus I? Out of these two, which is a better plus I group? Tell me. Huh? First one is a better plus I group. Why? I don't know. You just have said it. Which is a better plus I out of these two? Manvi, you don't know? I completed the whole Ramayana. What did I told? Samanvi, can you give the answer? Out of these two, who is a better plus I? Left or right? Right. Why right? Is better. So isn't it this is bigger? CS3, CS3, CS3. This has only two. If I did not write anything, it's a methyl group here, right? So where is more plus I, more donation? 2 versus 1, 3 versus 2. So obviously this is better, right? This is a stronger plus I. Isn't it clear? No? Okay. Huh? For of this order, I already told. It's simple. Bigger is better. 3 degree, 2 degree, 1 degree. That's it. Prefer alkoxy. Between alkoxy and alkyl, alkoxy is a better plus I. But among alkyl, if it's just alkyl, if it's just alkyl, please see this. Hope there is no doubt. Plus I order. Same goes for alkoxy. Follow the same order for alkoxy. Bigger is better. Okay. So bigger is a stronger plus I. Is it clear? No? Understood? Okay. Now next question. Guys, tell me what would be the decreasing order among these four. For SN2 now. Hope you remember SN2 depends on what are the following things. Huh? SN2 depends on, but why 1 degree, 2 degree? Steric hindrance. That's the right answer. Yes. So remember, smaller the group, faster is the SN2. So what do you think? Who will be the fastest? Because it says decreasing means fastest to the smallest. So what would be the answer? Online is everyone is getting it? Kindly confirm. Does anyone has any doubt? Ruhan, Subhanshu, Neha.
No, sir. No, sir.
एसी लो करना है टेम्परेचर. हाँ, लो लो लो. कूलिंग करना है ज्यादा. Yep. So what is the answer, everyone? Yeah, everyone. What is the answer? A D A D and then C B. Is this the answer? What you're wondering for? Remember, it is a wrong answer. Acha, new answer. A D B C. A D B C. Wrong. Guys, I literally listen to me now. I have literally handpicked one by one interesting questions and I gave those 15 questions in the worksheet. You know, these are worksheet questions. These are worksheet questions, right? So nobody bothered to solve it. If you don't solve it, you will obviously not get the doubt, right? Why these two are wrong? Because this is the common answer which is given by everyone. This is the most common answer. Now, if SN2 follows, if SN2 follows the least bulkiness, right? The least steric hindrance. So, without any doubt, any student would say A is the answer. But A is not the answer. Right? Right, Shashank? When you will solve it, then you will hit the doubt. No. Stop assumptions, making assumptions, guys. Write it down. Very important. Very, very important. All of you write it down. SN2 reaction factors. SN2 reaction factor. One you already know, that is rate of reaction is inversely proportional to steric steric hindrance. All right. Rate of reaction was inversely proportional to. Now there is one more secret factor that you need to know. Write it down. Tell me in SN2 what was the transition state we were getting? At same time there was a bond breaking and bond adding. Very good. There was no carb cation, right? There was no carb cation, but there is one factor. Remember, if there is going to be a electron withdrawing group, or we call it minus I. What do we call it? If there is going to be a minus I group, if there is going to be a, see, minus I group will slow the SN1 reaction, you just learnt it. But similarly, minus I group will speed up the SN2 reaction. Keep that in mind. So if you spot a minus I group, all of you write it down. If there is a minus I group, then rate of increases the rate of reaction. Please write it down first. We'll talk about it later. First, you write this. That electron withdrawing group or minus I group will increase the ROR. Reason, write it down. Reason, nucleophilicity increases due to minus I. Nucleophilicity increases due to minus I. So it makes the removal better and easier. Please write it down. Why are you jumping to the question so quickly? I hope it's clear. That is stabilizing the transition state. There is no intermediate state, but there is a transition state, right? So minus I will stabilize the transition state more and more. So reaction will be faster. That's right. Okay. I hope it's clear. Kindly note it down, everyone. Neha, Subhanshu, and Ruhan, did you guys get it?
Yes, sir.
Yes, sir.
See, remember, most commonly you will see this factor, but do not rule out the second factor. And if you spot a second factor, you will more prioritize the second factor. Is it clear? No? This is very common, but minus I. So the bottom line is, plus I group is directly proportional to SN1 ROR, and minus I group is directly proportional to SN2 ROR. But if you mix it, right, so can I say minus plus I will slow the SN2 and minus I will slow the SN1. This is the bottom line you need to remember. See, minus I plus I, entire grade 12th is based on minus I and plus I groups. All right. 11th May, I kept on telling you people that focus on GOC hydrocarbons, and now we move to 12th. Hope you are now understanding the importance of that chapter in grade 11, GOC and hydrocarbon. That is why after summer holidays, you will write an exam which will include all the portions what we have covered plus GOC and hydrocarbons. Yes. All right. GOC hydrocarbon including. So they are 11th, but for namesake they are 11th. They are again in 12th. Okay. Clear for everyone? Exam only on 11th? No. After summer holiday we reopen, right? So then whatever I'll complete plus GOC plus hydrocarbon compulsorily. Okay. That is for those people who are in willing to write the entrance exam. For those transition state, there was a transition state, right, where at the same time bond is breaking and forming, right? That it's not an intermediate state; it is a transition state. Clear? Okay. So now tell me what is the answer? What is the answer? Who is the fastest? Yes, now you got it. B is the right answer. B is the fastest. B is the fastest because CO is the minus I is spotted. CO is the minus I. So now answer will be B, A, D, C. There you go. This is the right answer. B, A, D, C. I hope it's clear. Got it? No? I hope you are getting it, guys. They all are 1 degree. Can you see? They all are. They all are 1 degree. I hope that is clear, right? 1 degree. All are 1 degree, right? But what is the deciding factor among them? This minus I. This will make the transition state more stable because carbonyl group is spotted. CO. CO minus I. Ridhima, hope you remember. I just told no sometime back. Do you see that? Minus I. Got it? So minus I faster SN2. So this first, then this, then this, then this. Bulkiness. And this whole thing is Sashank. Why C is not the answer? What is this whole thing? Huh? What is this whole thing? This whole bunch? Yes, that's plus I. You survived. Now, why we do rearrangement? Rearrangement happens in carb cation, no? There is no carb cation in SN2. SN2 doesn't have a carbocation. When I gave you the notes of SN2, I wrote it very clear one point, no carbocation. So no carbocation, no rearrangement. Is it clear? All right, everyone. Now your doubt are clear. Okay. These two were the very good question which I wanted to discuss. All right. Please solve the remaining 13 questions. For God's sake, all are very very easy. Okay. Only these two questions were from the entrance. Remaining 30 are from board exams. Okay. Now, now give the headline elimination. Samanvi, you were writing down something? Done? No. Okay. Elimination reaction. Uh, yeah. Huh. One second. This was SN1 reaction, I guess. Huh. Huh. So SN2, there is no carb cation. No carb cation. Where is the carb cation? Where is the rearrangement notes? Sunday I taught rearrangement. Show me the notes. Read this first line. SN2 has no carb cation. SN1 has a. So that is why we consider in SN1, not in SN2. Got it? All right, guys. So in substitution, what was happening? Substitution may what we were doing, one replaces the other, one nucleophile replaces the, but in elimination what we do, no any replacement, direct elimination, right? So and what we are doing in addition reaction, direct addition, no any replacement, right? So it's not wrong to say that elimination reaction is reverse of addition reaction. It is the reverse of addition reaction. Remember, guys, in addition, what was happening? The double or triple bond is changing into single. Unsaturated became, this is addition. In elimination, you know what happens? The saturated will transform into unsaturated. Opposite. Is it clear? Sigma bond results into sigma and pi. Got it? Sigma bond results into sigma plus pi. Whether it is 1 pi or 2 pi, that we will see. See, triple bond will form, two pi's will come when there will be a double elimination. Single elimination only 1 pi, double bond commonly. Is it clear? Ashna, it's okay, just a beginning. You will understand everything, don't worry. Now, so guys, write it now that there are three types of elimination reaction. How many types of elimination reactions there? Three. The first type is called E1, second is called, third is called ECB. E1, E2, ECB. I will tell. E1 is called unimolecular, E2 is called bimolecular, ECB is called conjugate base. E2 is called conjugate base. That's right. The good news is the most common elimination is this. All right. Second most common is this. This is rare. Rare is conjugate base. All right. So that is why The rare ones we keep it, discussions rare only. So we'll talk about this later, not required now. Okay, this is only needed for JE, and okay, but these two needed for board exam. Okay, very very important. All right, so we'll primarily focus on E2, E1 and E2. Later we will do ECB, that is conjugate base elimination. All right, now, so all of you give the headline E1. First, we will talk about E1 reaction. It's called unimolecular. And when we will do E1, I want everyone to have an idea going on in mind parallelly about SN1. Okay? When we will discuss E1, because you will find some similarity with SN1. So first point about E1, it is a two-step reaction. How many steps SN1 had? So correct. It is a similarity. Second, carb cation intermediate. Tell me how many, what was the intermediate in SN1? Bingo. So it's a similarity. So when there is a carb cation intermediate, chances of rearrangement. Remember, chances of rearrangement. I hope it's clear. Got it, no? Great. See, in SN reaction, we were using the word nucleophile, strong and weak. So SN1 was using which nucleophile, strong or weak? Similarly, E1 uses weak base. We don't use the term nucleophile, we will use the term base. So we will use a weak base, all right, such as CH3OH, C2H5, OH, H2O. So these are the, tell me in SN1 what type of solvent we were using? What do you mean by polar? Breaking off CX bond. What do you mean by protic? Kidnap, right? Capturing the removed nucleophile. Kidnapping the removed nucleophile. Similarly, E1 also uses polar protic solvent. E1 uses, I believe you are able to find the similarities, right? This is so much similar. Actually, there is one more similarity. Rate of reaction, huh? Because the reaction is nucleophilic substitution. Weak. Very good question. If we use a strong base or in SN1, if we use a strong nucleophile, then reaction will not wait for the removal of halogen and formation of carb cation. It will finish the reaction in single shot. So there will be no carb cation. So mechanism only will change. Manvi, your question was very good. Okay. So guys, remember the reason we are using weak nucleophile is strong base, strong base will not wait. Strong base will not wait for the formation of carb cation. So reaction will happen in single step. And you know what? Just like SN2, E2 will have a similarity. E2 will have a single step reaction. It will have a strong base. It will not wait for one step. And just like SN2, E2 will have a transition state. There will be no intermediate. There will be a transition state. And you know, in E2, what is the transition we call it? What is the transition state we call it? Anyone? See, in SN2, there is no name of transition state, right? But in E2, there is a name of transition state. It's called baby alkene. What do we call it? Baby alkene. Alkene. Don't call it alkene. It's a baby alkene, okay? Yeah. Baby, B-A-B-Y. Alkene, yes. We'll talk about it. So write it down. ROR depends upon concentration of alkyl halide. In SN1 also, rate of reaction was depending on, and ROR is independent of concentration of base. Base you add, you subtract, you make it half, you make it double. ROR will not change. Similarly, how in SN1 ROR was independent of concentration of nucleophile. There also it was depending on one factor, here also it depends on one factor. That's why it's called uni. Why do we call it unimolecular? Clear, no? Clear for everyone? Steric hindrance is not here. Carb cation is there. You are not able to see this bigger I have written here. It forms carb cation. So 3 to 1. Carb cation means what is the order? 3 degree, 2 degree and subject to rearrangement. You have to check. Write down one more point. Rate of R depends on leaving group. So who was the best living group, guys? Who was the best living group? Very good. Yes. RI, RBR and RCL. Write it down. So much. So many points I have given, and exactly same point was there for SN1. So E1 is nothing but a revision of SN1. No, it's not true. Now, whatever I'll write is going to be a difference. Similarity we have done. Now we will see a. So before I get into the mechanism, I must tell you an important note. Guys, a very, very important note. A very, very important note. So guys, please see this. Elimination competes with substitution reaction. They both are competing always. They are very strong competitors of each other. Just like in cricket match, India versus Pakistan is not a competition. India versus Australia, at least say something, yeah. Anyways, now mhm. No, I just said that why do we use a weak base? I and also pay attention. I'm not talking about strength of the base. I'm talking about amount, concentration. You got it, no? Concentration. N by V. Understood? Yeah. Competition. Competition. I'll explain. So, guys, pay attention now. Whenever nucleophilic substitution happens, when it is, when it is, or let's not elaborate so much, write it better. Whichever reaction, whichever reaction is preferred, whichever reaction is preferred, that forms a major product. So if so when you were studying the nucleophilic substitution reaction, In the background, in the minor product, in little amount, elimination product was also forming. You were not knowing about it. And when you will study, yeah, listen to me again. And when you will study the elimination reaction, you will also see in the background a very less amount of nucleophilic substitution product will be forming. So elimination is not purely elimination. Some amount of, little amount of substitution product will form. And substitution was not completely substitution. It was just the major product. And some amount of elimination product was formed. Is it clear? Huh? Don't complicate it. Racemic mixture was purely SN product. But what I did not taught you is there is something else was also forming. That was elimination product. Is it clear? There 50-50 is only major product of 50-50, not total of 50-50. Exactly. There is more product, yes, which I didn't tell you. Imagine if I would have told you at that point of time, then I would have to explain you elimination that point of time only. So, step by step. So, did you get it what I said? I am saying when you say elimination, that means elimination won. Some conditions it depends. I'll tell you one thing that decides who will be major and who will be minor. So, if substitution is major, that means substitution, when we say reaction is substitution reaction, right? Nucleophilic substitution, that means its product is major and elimination is minor. When I say elimination reaction, it means elimination is preferred, so substitution product is minor. I hope that's clear. That's why I have written elimination reaction competes with SN1 reaction. Okay, write down one last point. Both reaction both reaction occurs simultaneously. Both reaction occurs simultaneously, side by side. They always compete. Okay. Whoever wins forms the major product and we call that reaction it is. You understood? Is it clear? Neha, Shubhranshu, Rohan, did you get it?
Yes, sir.
Now,
Yes, sir.
Now the question arises, sir, what are the factors on basis of which we will be able to tell it is nucleophilic substitution and we will be able to tell it's a elimination. So write it down, 1 minute Mali. So write it down, elimination reaction is, do you know nucleophilic substitution, what was common between SN1 and SN2? Only one point was common between the two. What was it? What was common? Yes, very good. Both reactions were exothermic, so they were favored at low temperature. Write it down. Elimination is endothermic. Reaction is endothermic, so favored at high temperature, not high, higher. So it is the temperature which decides who will win. Got it? Both will compete with each other, but temperature will decide who's gonna win. So write a note when the temperature is up to 20 degrees Celsius, SN favored. It is favored SN reaction. If it is 50 degrees Celsius or above, elimination favored. So I hope it's clear. Guys, please tell me, did you all understood? Samanvi, you got it? Because when I was explaining this part, I felt many of you were feeling, what is this? 11th was better. It's better, 12th is better. Samanvi, did you get each and every point because you were not there in the last class? Did you watch the recording? Okay. So now you might ask me, sir, What if it is between 20 to 50? Who will be favored? So basically, it will still be, elimination will be more favored. It will, up to 20 only we see SN reaction, okay? Is it clear no? So guys, remember when I say SN favored, that means it is major. And elimination is, who is minor? Elimination. And when I say elimination is favored, that means this is major. Then who is minor? SN product is minor. Got it? So you have learnt all the introduction of elimination. It's time for mechanism. Mechanism. Write it down. Yes, tell me. Base. Nucleophile is called as base. Yeah. But the method is same. Remove the proton. Rest is okay. Neha, do you have any doubt? Subhanshu, Ruhan.
No, sir.
No, sir.
Okay. 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 All of you write down mechanism. Guys, write down the mechanism. So step number one, formation of, what was the step one in SN1 reaction? So write down same formation of carb cation. In SN1, which step was the RDS? Step number one was the slow step, that's called RDS, right? Same thing, this step is the RDS, slow step. This is the slow step, so hence this step is rate determining step, RDS, okay? Now let's take example. So RCHX. So in step number one, what will happen? Polar protic, right? Polar protic. So what it will do? Polar protic solvent. It will cleave the bond, right? Oh, sorry, wrong number. It will cleave the bond, right? CX bond will break. So as a result, what will happen? The halogen will get removed. This halogen, what it will do? Polar protic, what it will do? It will capture it. Polar protic, no, it will capture it. No, captured. All right. Now it can die in peace. All right, captured. So as a result, what do you get? Step one, formation of carb. Clear, everyone? Guys, I really don't want you to discuss and talk other things. Stay focused. Exam is very near. Yep. Which exam? The day chapter will end, the next day you'll have exam. very soon because I'm covering almost the basics now. Huh? One second. Approximately, guys, note it down. Don't ask me again. Subjective board pattern exam, full haloalkane halorine, not 3 hour. Note it down. One second. No. I hope it's clear. Totally, three exams are going to happen. First is board pattern haloalkane halorine. Second, NEET and JEE, those who are interested for competition, they will be writing this exam. But this is compulsory for everyone who is writing the board. So that is for GOC hydrocarbon and haloalkane halorine. I hope it's clear. So, uh, who is not appearing for entrance, whether it's engineering entrance or medical entrance? Okay, not appearing for entrance exam, any form of entrance exam, not appearing, right? So those who are not appearing for entrance, this exam is not for you. All right, clear with everyone? Got it? Huh. That's this year, so nobody's giving, anyways. Next year, but your focus is then you will appear on this exam. All right, then you will write this exam. Huh? Halorine is ARX, Haloalkane RX. We will learn. So that is the deadline I have kept. Before that, I'll finish. Got it? I am taking a long time to finish this because first chapter has all core concepts. Okay, elimination, substitution, all this will repeat in the remaining. Clear, no? What do you think in alcohol will do something different? No, same will do. Only molecule, substance will change, concept will the same. I mean, little bit here and there, but this is the core structure, okay? So those who understand haloalkane halorine properly will not face problem in the remaining chapters. Got it? So this exam is, so it's not wrong to say this is a litmus exam for you. I have to see who lies in blue and who lies in red. Shashank, your paper I will correct first. All right. Is it clear? Whoever fails in this exam will have a compulsory 4 p.m. attendance and will come for extra practice. Yes, that's mandate. 4 p.m. All right. Huh? No, he passed because he still wanted to come. Yeah, that's the passing. Huh? 90 minutes. 90 minutes. Yes, this paper will be 90 minutes and 45 marks. 45. All right. 50% will be MCQ, 50% will be subjective. Understood? That's board pattern. Board pattern is also like that. Yes. Ratio MCQ and subjective, it will be balanced. Almost 50-50. Yeah. Is it clear? I hope nobody has doubt. Neha, Subhranshu, and Ruhan, have you all taken a note of it?
Yes, sir.
Yeah, marks
Yes,
will
sir.
be 45. And one more thing, guys. The results will be announced publicly. Don't expect me that I'll give you in years personally. Oh, Shashank, you have done excellent. And Prachit, you have failed. I'm so sorry. No, don't expect me that. I am going to publicly post the results. So please work hard for this. Yes. Yeah, one more thing. I can assure you the paper will be simple and direct from NCRT and from the class what I'm doing. Yes. First exam, passing marks is 70 because the paper will be easy. Yeah. If you want a hard paper, I can reduce it to 45%. 70. JE 25 questions, 100 marks, plus 4 minus 1. And NEET, you will have NEET paper, so that will be as per the NEET, okay? 180 marks, 45 questions. Sakshi, you're getting it now? Ajita, same. You will be writing 45 questions. JE people, 25 questions. Time, same, you know. I will give you the time. Hey, for one subject, 3 hours, right? Okay, 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 done. Guys, now pay attention. Today is 8 and exam will happen approximately 23rd, 24th. So you have a really good time. You can literally finish the NCRT book. Okay? Make sure you solve all the questions of NCRT. Now pay attention here. So did you all understood the carb ketone is formed? Step 1, right? We got the carb ketone, right? Pay attention guys, what happened? Step 2. So in step 2, let's bring the base. Guys, can we write CH3 like this? It's the same thing, right? Just say, just for explaining the mechanism, Ashmita paid attention here. CH3, I have written it like this. Are you all feeling hot or something? Okay, one second. Let me turn this on. AC will take some 2 3 days. Just a second. Yeah, this is better. This is fine though. Yeah. Do you want more speed? Yeah, it's fine. Now, Kavish, turn on the speed of that. It's at 5. Make it 5. No, 5 is not there. Okay. Huh. Tentative, I will announce. No, you have to compulsory write on one of the days. Then you will write early? Yeah. Okay, guys, stop the discussion of exam. Manvi, stop the discussion. So when you will add the weak base, right? Let's not specify it now. It's a mechanism. Tell me, why did I add delta here? Why did I heat it? Yes, because it indicates it's favored at high temperature. So the minute I'll add a base, it will take out, guys, understand, the carbon which has a plus, it's called alpha. What do we call it? So the neighbor carbon will be beta. So understand, guys, there what we are doing is, we are doing alpha beta elimination. What we are doing? What is happening? We are doing alpha beta elimination. First hydrogen is removed. My bad. First halogen is removed and now hydrogen will get removed. So when base will pull out the beta hydrogen. So understand all of you what happened. Very nice. Yeah. Now, so guys, beta hydrogen will get removed. Pay attention, all of you. So this will go away. This will be removed. As a result, what will happen? Now, when hydrogen will leave, these two electrons, these two electron will be donated to carbon and it results in double bond. So as a result, what do you get? RCH double bond CH2. This is how elimination occurs. So ultimately, what did you remove? Hydrogen and halogen. Hydrogen and halogen. Alpha beta, and between alpha beta elimination, you get a double bond. Between alpha beta, you get a. So who was alpha ultimately? The one which contains halogen. The one which has a halogen is alpha and neighbor is beta. From beta you remove hydrogen, from alpha you remove hydrogen. And between alpha beta there comes the double bond. That's right, okay? So that is why it's called alpha beta elimination, also known as dehydrohalogenation. What do we call it? Also known as dehydro. You have studied this in 11th. Not sure you remember this or not. And now will come Sedgwick rule. Is it clear? Why it's called dehydrohalogenation? D means remove. D means remove hydrogen and halogen. So HX is removed. I hope it's clear. But I have told you. But what did I told you? Very good. I have told you in the background there would be a SN product also. So guys, can you write the SN product? What will it be? The HX will replaced by, let's say, no, I have not mentioned, let's say OH. Let's say it was OH. Let's say it was OH. अरे ठीक है, because I added water, assume water is there. So what would be the answer? So this is the minor product. I have told no, both reaction compete with each other, right? This is the SN product. The halogen was replaced by OH. I hope it's clear. Got it? Okay. Can you write me major and minor products? Guys, can you write me major and minor? Yeah, solve it. Subhranshu, Neha, and Ruhan, solve this. For? Will do. When he'll come here, no, then we'll do. Okay. Sunday, no, हाँ, तो fine. हाँ, okay. Anyways, pay attention to this. Ashmita, you need to solve this. You're still thinking, now start solving. 60 degree. Tell me who will form the major product? 60 degree means? Yes. Now, so the carbon which has a halogen, that's alpha. Next to, quiet. What is the degree of this beta? This is 1 degree. And what is the degree of this beta? So it doesn't matter. You remove from any one of the place. And between alpha beta, what comes? Done. So answer is, did you all get this answer? And what is the minor product? This is the major. What is the minor? Yes. Anudeep, can you show me the minor product? That's a wrong answer. Wrong answer. Samanvi, I have told you how to generate a nucleophile. One second, one second. One second. What did you add? And when you remove a positive part, what is will left here? OCS3. That's it. Remove the positive part to generate a nucleophile, which is that. What is this? CS3OH. Remove the positive part and generate a nucleophile. Attack it. That's it. What? Huh? How do you generate a nucleophile? So what is left? So what do you get? Samanvi, it's not your fault. Everyone did the same. Guys, pay attention. I have told no to remove the positive part, right? To generate a nucleophile. So this is your SN product, right? This is the SN product and this is the minor product. Why SN is the minor and why it is major? 60 degree. High temperature. That's right. Clear everyone? Rutvik, you understood? Daksh, are you paying attention in the class? Anya, did you get everything? And Rutvik, you followed up? Okay. Next question now. Next question. Let's not stop. Just get me, just get me the SN product elimination. I will teach you. Okay, okay, solve, solve, solve. Guys, I believe you are not going home because I will stretch the chemistry till 8 p.m. Then Raji will not leave you before 9:30. Everything is fair in grade 12. Understood? Yes. So, huh? I'll tell you, ask your seniors. I have took the class till 12 midnight. Yes. Okay. Guys, no break. Now, should I talk now? If you let me talk, the class will end in 5 minutes. Ha. So now see this in this question. In this question, who is alpha? Who is beta? What is the degree of this beta? What is the degree of this beta? So Setzef rule is applied in elimination 1 E1 reaction when you have multiple beta of different degree. So because of difference in degrees, multiple beta, we have two products. Just two products of elimination. And one product will be when you remove from this hydrogen, and one product will be when you remove from this hydrogen. So let's assume this is beta 1 degree, this is beta 2 degree. So I'll write the two product, that is one I am writing it from beta 1 degree and one I am writing from beta 2 degree. So when I remove from beta 1 degree, what do you get? Between alpha beta double bond, right? Put double bond. So you'll be getting CH3, CH2, CH, double bond CH2. Correct? We got this. What do we get here? CH3, CH, double bond CH, CH3. So this we got the beta 2, alpha beta. Once the double bond came here, once it came here. Clear? Why two product of elimination we got? Because we had multiple beta of different degree. But the question arises, who will be the major of elimination and who will be the minor of elimination? So Setzef rule is used in that case. Setzef rule says more alkylated alkene is more stable. That means focus. First of all, you should surround the double bond. Surround, box the double bond. Now tell me how many alkyl groups are there? 1 and 2. And how many alkyl is there? Just 1. See, size doesn't matter, number matters. Prioritize the number over size, okay? So how many are there? 2. And how many is there? So which is more alkylated? Exactly. So that is why it's a major product. What is it? And this is the minor product of elimination. Is this clear? Guys, stop the discussion first. Let me talk. Manvi, pay attention here. Will let me finish. Now you will ask me, sir, why Sedgef rule is saying more alkylated is more stable? Why Sedgef says like this? Secret is, the real concept is hyperconjugation. The carbon which is connected to double bond is a alpha carbon. Alpha has a many definitions. So how many alpha hydrogens are there? 3 plus 3? 6. So this is 6 alpha. And how many alpha is there? Only 2 alpha. So 6 versus 2 alpha. Who is more? That's why it's major. So Sedgef rule is based on hyperconjugation. Remember, more alpha hydrogen, stronger hyperconjugation. So more stable. Is it clear? See, in elimination, guys, pay attention. In elimination, we say alpha carbon, that carbon which has a halogen. That means we call it that carbon alpha which has a carb cation. Carb cation carbon is alpha. But when it comes to stability of alkenes, we call alpha hydrogen which is directly connected to double bond. So which carbon is directly connected to double bond carbon? This and this. And their hydrogens are called alpha hydrogen. So 3 plus 3 is 6. Here only this is alpha. This is only connected to a double bond carbon, right? So how many alpha hydrogen this carbon has? Just 2 alpha, right? So 6 versus 2, 6 is more stable. And those who don't understand any of these, for you I have a one line. That is higher degree beta is more stable. So major product. That's it. If you don't understand any of these, then just remember this. That is more than enough for you. So now tell me, this is how many degree beta? This is, so who will form the major? That's it. Is it clear? Higher degree beta, more stable product. That's it. Not done. Now tell me what is the SN product here? What is the SN product here? So SN product will be, this is the SN product, right? This is the SN product. One more thing, guys. One more thing. Yeah, Rutvik, what is your doubt? One more thing. You might ask me, sir, why did we get elimination ka two products, major and minor? Why we didn't get in above case? So in the above case, both are of same degree. Betas are there, multiple beta, but the degree was same. That's why. But here degree was different. That's why Sedgef rule came. Understood now? Now, when you are applying a Sedgef rule and when you call a major product, it's called also known as Sedgef product. Write it down. It's called as, and when you find a minor, it's called Hoffman product. The major is called Sedgef product. The minor is called Hoffman product. Very good, Prachit.
So,
Yeah.
if there's a double bond already existing in the question,
Huh?
if there's a double bond already existing in the question
Huh?
for the 1 degree, so should we take 1 degree or 2 degree?
If double bond is already there,
There's a set of if the question was CH3, CH2, CHBr, double bond CH2. Yeah.
you will still remove HBr. Understood? No. So double bond will become triple bond. Understood? That will you do in the next class, what you're asking. Okay, is everyone done? Okay. So last question before we end the class. One last question because I need assurance that you have understood. Yes, Archita, you have any doubt? SN product I wrote no here SN. Is it clear everyone? So one last question guys. Guys, get me the answer. Last question. All of you solve this. Ruhan, do you have any doubts so far? Subranshu, Neha.
No, sir.
No, sir.
See, I'm stealing the maths class time now. I just hope it doesn't come up. Yeah. Yeah, solve this. My plan was to do three more questions, but that's okay. Next class will do. You did? Did you do the rearrangement? Very nice. Guys, what is the carpitan will come here? 1 degree. Neighbor is? Are you getting the hint? So there will be a rearrangement. And Ashmita, do you know how to do rearrangement? Yes, you will watch the recording. So you can just observe. Leave it. Yes. You know rearrangement, right? You attended the class. You also didn't do. But you told me Advika taught you, right? So do it. No, she told me that Advika taught her. Guys, solve no? So all of you understand now. Tell me out of the two, which is SN and which is elimination? Yes, this is SN, this is elimination, right? One thing is common, there is a carpitan in both. So what will happen when I remove this? There will be a carpitan. Let's form a carpitan, guys. So CH3, CH, CH3, CH2 plus. Now what will happen as a result? The hydrogen will migrate here, right? Hydride shift will take place. Ashmita, understand what is this? Whenever there is a carpitan, this is 1 degree. Neighbor is 3 degrees, so it gets promoted by donating hydrogen. So hydrogen will go from here to here, so that plus is gone. And plus will appear here. So after the rearrangement, what will happen, guys? So after rearrangement, what happens? C plus will come here. And this CH2 now become CH3 rearranged. So 1 degree carpitan increased its stability to 3 degree, get promoted. So now all reaction will happen according to this. So as a result, OH will come here. So SN product is this. That's all. It was very easy, right? Tertiary butyl alcohol, we got this. Those who don't know, they will write CH2OH. But those who know, that is the right answer. Is it clear? And similarly, now this carbon, understand elimination product. Now this carbon is alpha. This is beta. This is beta. This is, what is the degree of this beta? This is 1 degree. This is, so it doesn't matter, remove from anywhere. So the elimination answer will be CH3C double bond CH2 CH3, done. That's it. Yeah, that was the answer. But now you understood? All right. Neha, did you understood this? Both the products? Subranshu, Ruhan?
Yes, sir.
Okay. Ruhan, Subranshu,
Yes,
did you all
sir.
get it? Okay.
Yes, sir.
Aryan, did you got the answer? How rearrangement how rearrangement influence the reaction, right? Did you understood or not? Wherever the carcation comes, that is the alpha. Remember. So neighbor say you remove the hydrogen and put alpha beta के बीच में double bond. That's it. You understood now? Done. You understood, Sanjay? Anu, did you understand? SN1, you know, right? OH will be the nucleophile, right? Proton you remove, it remains. So OH will form here, no, in the carcation. In the promoted carcation now. The promoted carcation pe OH will come. You understood, no? That's it. So SN only I'm telling. This is the promoted carcation, right? This is the SN reaction. And this is the elimination. This is elimination. Anu, you understood? Vijay, you understood or not? All right, bye everyone.